We got up to inheritance last time, but we didn't formally define it. And so that's what we're going to do today with, like all the other demonstrations that I've done, we won't introduce the concepts. Instead, what we'll do is we'll do a demonstration and then go back and fill in the blanks of all the concepts. Just to get it started though, inheritance basically allows you to extend or extends the behavior of a superclass into a subclass. So we're going to start with this hierarchy of things, right? We've got a parent-child relationship, or a superclass, subclass relationship, or a class and a derived class relationship, where common functionality and state and behavior, you can put that into the superclass instead of the subclass. That way, everything that extends it, everything that's a child of it, inherits that behavior, just like a child would inherit the genes and behavior of their parents. However, you can specify more specific behavior or specialization in that subclass by overriding stuff. So just as you are the product of your parents' genes and maybe a little bit of their behavior, you can still do things your own way, right? You don't have my kids don't have to grow up to be computing professionals or whatever. They can go off and do whatever they want. To understand this, what I want to do is I want to go through a demonstration now of building just a small financial application. We're going to support two types of assets in this financial application. A savings account. A savings account is something that you go to the bank, you throw a bunch of money in there and you let it sit, and they pay you interest on a monthly basis using some annual percentage rate. Right? We also have an annuity. Now, an annuity is a different kind of product. Mostly annuities are not good investments. But an annuity is a product that pays a fixed monthly amount over a certain number of years. So you could have an annuity that pays you $500 a month over the next 10 years, right? And then after that, it's done paying out. You have to buy the annuity up front, right? You can't just say, oh, give me $500 a year or give $500 a month or something, right? You pay, what would that be? Monthly $500 for 10 years would be, I can't do the math in my head. It'd be some dollar amount. Basically, to buy that annuity, you would pay some smaller dollar amount, right? So in other words, the annuity manager is hoping to make money and pocket the additional interest that they get on any investments. But you have a guaranteed payout, right? That's what an annuity is. So let's come over here to demo, and I'm going to go ahead and get rid of everything that we've done here. Right? And I'm going to note here that to do, I want a savings account that has $100 in it. We won't get too greedy, and pays 5% annual interest rate. Right, whatever. To do, I want an annuity that pays, say, $500 a month for 10 years. Right. So of course I could go ahead and put that into the demo here and create a bunch of variables, but that would mean that I'm not creating a class, right? And that means I couldn't have, say, 2 savings accounts or 2 annuities, or another user in my financial application would not be able to own an annuity and a savings account. So the first thing I'm going to do is start by defining a class. Let's take care of the savings account first. What should I call this class? Savings account? Savings account. Account, not accounts. There we go. So remember class design? Semantics dictate design. Where is it? Where was it? Darn it. There we go. Semantics dictate design. So all you have to do to design this class is to think about what you want in it, right? For example, I want an account that has $100 and 5% annual interest rate. So what does that immediately tell you that you should put into your savings account? How's that? What do we call that? $100. Call that the principal. If it's a loan, it would be principal. But if it's a savings account, it's balance. There we go. Could also be balance in a loan, but like the remaining balance or something like that. Right? And that's going to be a double. Right? Now, immediately, what could you do and say, well, okay, doubles are not very accurate, right? In fact, in real financial application systems, they don't use doubles. They use currency or they use integers to represent a whole number of cents, right? Should we go that far? Currency. Should I go ahead and, okay, before I even start, I need to go create a currency class. Before I even start, I need to go and do this, right? To do the currency class, I'm going to have 50 hours of work just to do that. Right? There should be one built in, isn't there? Localized currency. Yeah. Java.util currency. So when you are building something, you break down real world objects into ideas into smaller and smaller parts until an object already exists for it. I could use currency. But that gets me into that other principle we talked about. Do I really need this yet? Do I need a sledgehammer when a hammer will do? No. Yagni, you ain't going to need it yet. Now, later on, maybe I do. Now I do. I'm going to scale up my operations, or this is actually going to be a real financial application, and we have to then adhere to, federal FTC regulations or something like that, in which case I do need the currency. But for now, you ain't going to need it. Okay? What else? It pays 5% annual. So that's another double. And we call that thing an APR. What does APR stand for? Annual percentage rate. How did you know that? You have a savings account, right? Okay. So anybody that has not had a savings account, would you know that what that is? Probably not. What's a better term? Annual percentage rate. Right? Now there's some debate there, right? If we're in the context of a financial application already, right, then we're going to assume some minimum level of knowledge about the finances that you're implementing or that you're modeling. And so APR, I spelled it wrong anyway, but APR is probably okay, at least in this context. SSN, what am I doing there? Social Security number, right? COC? Say what? Oh, Clash of Clans. See, no. It was there is a form that you have to fill, conflict of interest. Right? So I just had to fill this out for a bunch of folks in order to get a grant for some travel. And COC would be conflict of interest forms. You have to attest that you represent no foreign governments in order to get money from NASA. Right? It was a big pain in the butt. But I got to know COI and COC very, very intimately, right? As well as export controls. I never want to have to think about that crap again. So, APR, yeah. Social Security number, probably. COC, Clash of Clans, no. So then you would actually want to spell it out there. I'll go ahead and go with APR for now. That's good enough. Why? It's not really the Yagni principle, but again, in engineering, what's better than good? Good enough, right? Just move on. Right? All right, a balance in an APR. Okay. Anything else? All right, let's jump back over here and review what objects are. An object has state, that's what I'm going through right now. It also has behavior, that's what we'll eventually go through. But what about identity? How do you identify a savings account? Account number. Right? That's going to be my object's identity. If this were being stored in a database, it would probably be the primary key of that database. If this were a person, how is a person uniquely identified, at least in the United States? Social Security number or a tax ID number or something like that, right? How is a book uniquely identified from your lab on Wednesday? ISBN, right? So what is an account number? Could be an integer. Right? Just like NUIDs are. Nebraska University identification number. Except that how many people's NUIDs start with a 0? Oh, nobody in here? Okay. At least 10% of you should. And then at least 1% of you, of the population, begins with 2 zeros. I have yet to find anybody that begins with 3 zeros, though. So they must not allow that. But if I were to print that out, would the leading zeros be printed out if it were an integer? Probably not. Maybe you want to go with a string. Why? Because oftentimes account numbers have hyphens in them. Account numbers have, letters in them, an alphanumeric code, right? In which case, probably a string. Right? Okay. Anything else? Let me come back over here to demo and emphasize something. I want a savings account. How do you know that this savings account belongs to me and not to somebody else? Okay. An owner? What is an owner? Okay, what if it's a string? Then what's the owner? Is it going to be Chris Burke? Or is it going to be Burke Chris? Or is it going to be Christopher, Michael, James Burke? I never use my third middle name or my second middle name. Why? Because most forms don't allow it. So we'll just go with that, right? J. Right. I'm not a junior, but if I were, junior. Right. So, string. Anytime you have more than one piece of data, a first name and a last name, what should that be screaming out to you? Make a class. And I'm going to cheat and come over here and steal one from the other class. There we go. Yeah, whatever. Let's take a look at it before we move on, though. Right? Represents a person. Good Java doc, right? This section had no problem with it, but every class and every non-trivial method requires documentation, right? Almost everybody did that. First name, last name, my date of birth. A list of emails, which are strings. You could, of course, make an email class if you wanted to. Yagni, you ain't gonna need it, right? String, all right. What else have I done up here? If you wanna watch the videos, what I've done is I've made a person comparable. That means that you have this compare to method, that if they have the same last name and the same first name, then they're equal. Because the example that we did in the other class was I had a bunch of books by Frank Herbert and a bunch of books by his son, Brian Herbert, and they were all being thrown into the same set. Why? Because I did not have identity. Right? That Frank Herbert and Brian Herbert ended up being the same person because I was just using the last name and the last name only. Right? So what we did is we overrode this, created a compare to method so that the last name and the first name are relevant. I, of course, could change this, since this is now a financial application, into a social security number. And that becomes my identity. If this is tied to a database, maybe my database key ends up becoming the identity. Right? It's all about design. Okay? Otherwise, first name, last name, bunch of getters, a public constructor here that takes a first name and a last name and initializes that array list of strings as in emails. Get date of birth, getters, a way to add emails after you've created a person. So here's my person. If I didn't have this add email functionality here, right, that adds it to their list of emails, then I would have forced you to specify all of the emails up front. String emails. Emails, there we go. So that they have a Huskers account and they have a UNL account and a Gmail account and for whatever reason, a Yahoo account, right? Are Yahoo accounts still a thing? Sometimes. Right. There we go. Right. So it's a little bit more flexible in that you can go ahead and add an email later on if you find one. Okay. A toString method that simply has a last name, comma, first name. That compare method that establishes uniqueness or comparable. And then a hash code and equals method that also establish an equality between a first name and a last name. Do you think I wrote any of this code? Nope. What did I do? Source, generate hash code and equals method. It took care of it for me. In fact, you can generate that. Well, it already is here. Yes, whatever. Right. I want it to be based on not everything, or I want it to be based on just the social security number, or I want it to be based on the first name, last name, like the demonstration I did in the other section. I'm going to cancel this because it's not that important just yet. Okay. All right, now that I've got a person, I can come back over here and make my person, my owner, into a person. Why is that so much better than a string? Well, first of all, is a person a string? No. A person is a what? A person is more than a string. They're two strings. They're a first name, last name, right? Well, no, that's not it. Right? They're a social security number. They're a date of birth. They are a list of emails, right? Again, this goes into composition. That there we go. Where is it? Composition constructed. Yeah, there we go. Generally, objects are composed of other objects. Anytime you find yourself saying, "Oh, it's just a string," really rethink that, right? Is it just a string, or is it other things along with it? And even if it is just a string, is it different strings like first name, last name that you might want to keep separate? If so, you need to define an object. Okay? All right. That's good. Encapsulation. I'm grouping a bunch of pieces of data together that define a savings account. Am I protecting that data right now? If I just made everything public, you can do whatever you want with the account number. You can change it, you can delete it by making it into null, et cetera, et cetera. What should I be doing instead? Protecting that data. Private final. There we go. Now, of course, it's not going to compile. Why? Because if something is final, you have to at least set it once. And so I'm going to go up here to source, generate constructor using fields, and be done. Okay. I'm going to generate getters and setters, except that I'm not going to allow you to set anything. I can't allow you to set anything because they're all final. And so I'll go ahead and do getters. Done. Right. What else would you want? Maybe you're going to print it out at some point, right? A toString method. Right? And I'll choose everything, deselect all. Let's go ahead and go with just account number and balance. There we go. Savings account, account number, savings account number, and then percent %s account this dot account number. All right, and let's go ahead and format currency. How do you format currency? $. 10. How many decimals of accuracy should you have? 2, right? F, and that's going to be this dot balance. There you go. Now in your project, eventually, not on the first phase here where it's just EDI, but on the second phase when you're actually producing a report, do not rely on printf or the string dot format to do your rounding to cents for you. This does not round to cents. It rounds to cents for the purposes of printing it out, so it will look rounded, but it's not actually going to be rounded. Right? What else? Well, we've got a whole menu here of things we can do, and just because you can do it, you should do it, right? Yeah, let's go ahead and do it, right? Hash code, sometimes that's true, right? There we go. There's a equals and hash code method that is based on everything. It's based on the account number, the APR, the balance, and the owner. Now, that's not what I meant. I meant that two accounts are the same if and only if they're based on, where is it? Equals and hash code. If and only if they have the same account number. Okay, if that's what you want, go ahead and generate it. Right? So that that account and that account are the same accounts if they have that unique identifier, that account number. Right? Great. Done. I want a savings account that has $100, savings account. S is equal to new, a savings account of, what was the order? Account number, I'll just make something up. 1, 2, 3, 4, 5, A. And $100 and me, $100 and 5% annual interest. We'll go ahead and go with a scale of 0 to 1, so that 5% is 0.05. Okay? Now what do I need to do? I need to construct me. So person, me, is equal to new person, Chris, and then my last name. There we go. Burke. Yay. I want a savings account that is $100 and pays 5% interest. Once I'm done with something, is it a to-do anymore? Nope. Most people got rid of their to-dos. Almost everybody got rid of their to-dos, like they should have. I'm just emphasizing that for the other section, right? Do you leave to-dos in your code? No. You're done. It's not to-do anymore. You're done. Okay. Great. Let's print it out. System.out.println s. And it should have $100 and, oops, I screwed up this is why we do ad hoc testing. Percent 10.2f. Run that again. Yay, I've got $100. Cool. I don't think I actually, yeah, I have a savings account, but there's not $100 in it. There's $50 in it so that I could get into the Centris Family Fun Zone at Chasers games. Because you show your card and you get in for free. Right? Speaking of which, baseball begins tonight. NCAA does. All right. I want an annuity, and I did spell that correctly. Oh, no, I didn't. There. Annuity that pays $500 a month for 10 years. I did spell that correct. It doesn't know what it is. Right? So, same process. What should we do? Create a class, and I'll call it annuity. Tell me, what's an annuity? Does it have a balance? That's not what it sounds like anymore. It pays you a monthly amount for a fixed number of years. A term, we call that a term. Right? So int term years. Right? And double monthly payment. Okay? Once again, I'll emphasize, I want an annuity. What should I do over here in this class? An owner, right? Also, we want identity. How are you going to identify an annuity? Same exact way. I'm going to steal both of those things and bring it over here. Right? So I have a way of defining an annuity that has an account number. An annuity is still an account, right? I know who the owner is, me. I'm going to go ahead and protect the rest of this stuff with private final. There we go. Now go through the same process. Generate code, generate code, generate code. All I'm going to do right now is generate constructor. And because we're going to, ultimately, we're going to change this. Right? Okay, let's come back over here to demo. And remember, I wanted an annuity. Annuity A is equal to new annuity. I don't know. There we go. Me, and it's going to be $500 for 10 years. There we go. Oh, did I not save that? String owner double int. String, oh, comma, duh. There. I did it. And of course I would have to override the toString method to get it to print something that made sense. Okay? Now, all of that is without any inheritance whatsoever. Now let's revisit inheritance. Inheritance allows you to reuse a class by extending its behavior. The reason that you would want to do this is for code reuse. Remember the DRY principle? Do not repeat yourself. Let's come over to these classes, and I'm going to go ahead and can I do this? There we go. Let's look at those two classes side by side. Right. Do I have any? Let's go ahead and get rid of that. That's not necessary at all. Do I have any redundancy here? Do I have any repetition that's violating the DRY principle? Don't repeat yourself principle. What? The account number and the owner. In fact, I just cut and pasted those. These two things, a savings account and an annuity, have common state and probably common behavior if I really think about it. Right? What should I be doing? I should be taking that, and instead of repeating it here and repeating it here, creating a new thing above it. Right? Now, to understand that, let's go ahead and look at another kind of trivial example before we go back. Right? Example: animal, dog, cat. Right? Tell me what is the relationship between those three things? Is a dog an animal? Yeah. Is a cat an animal? Yeah. So a cat and a dog are both animals. But is a dog a cat and is a cat a dog? No. So this is what's called invariance. These two things are not the same thing, but they have a commonality. They're both animals. Now think about the other way. If I've just got a generic animal in my hand right here, right? What kind of animal is it? I don't know. It's just an animal, right? It's in a box. You can't even see it, right? Is it a cat? Could be, not necessarily though. Is it a dog? Could be, not necessarily though, right? You open up the box, you find out that it's a cat, all right, and okay, now it's a cat. But otherwise, a dog and a cat are animals. This follows an is-a relationship. These two things are animals, but an animal is not necessarily a dog. This is called covariance. This is called contravariance. This is called invariance. And this triangle that gets formed is something that we'll talk about later. But you already see that there's going to be commonalities between a dog and a cat, but there are also going to be differences. There are going to be specializations. I've got a savings account and an annuity. What would you say these two things are the same of? Are they both animals? Obviously not. What are they both? Accounts. I like that. It says it in the name, right? So let's go ahead and create a new class that represents an account, right? What I'm going to do is I'm going to take the things that are common to both of these and I'm going to promote them up to the account class. Now, does every account have let's go ahead and get rid of this. Does every account have a balance? No, an annuity doesn't have oops, where'd my annuity go? There it is. Didn't want to close that. Does an annuity have a balance? No. Does a savings account have a monthly payment? In some sense it does. They pay you interest monthly, right? But not really. That's not what we mean by that, right? So over here with an account, it has these two things, okay? So I have to go through the exact same process here of at least generate a constructor using fields. Great. Right. Generate a two-string method, generate getters, not setters because they're final, generate equals hash code, ... right? But now, how do I say that a savings account is an account? How do I say that an annuity is an account? Just like a dog and a cat, they're animals. But a dog is not a cat and a cat is not a dog, just like an annuity is not a savings account and a savings account is not an annuity. In Java, I use the extends keyword, okay? Come over here to savings account and I'll say that it extends an account. There we go. That means I can get rid of these two things. Because if it's a parent-child relationship, the child inherits everything from the parent. The parent, in this case, is an account, and it has an account number and an owner. Right? And so a savings account will automatically inherit those things. Right? In fact, should we call it savings account if it's an account anymore? No. Just like we wouldn't call it a dog animal or a cat animal, we know that they're animals. So let's go ahead and refactor this. Refactor, rename, savings. There. Yeah. Okay. Now, do you see that super that was generated? And I told you, like, if we did it with isotope or something, that to ignore it. Right? Now we can't ignore it. If I've got a parent-child relationship and I create a brand new child, I also have to make sure that that parent is created. It's kind of anti-intuitive, right? Because a parent has to exist before the child, right? Okay. It's not really a parent-child relationship. That's just one way of thinking about it because of this nice family tree, right? All right, so what we need to do is when we create a savings account, I've got an account number and an owner. All right, who actually owns that stuff? The parent. I just inherit it. So what I need to do is I need to call the parent's constructor. That's what super does. My super, just like this, calls another comparator or calls another constructor in the same class. Super calls the superclass's constructor. And here I'm going to pass in account number and owner, because I can't set them down there anymore. Yeah.
You're like doing double inheritance. Can you go like super and then super inside the super, or is that like
That's a good question. You would delegate to the super, and then they would be responsible for calling the super, right? Because grandparent, parent, child, you shouldn't have to think all the way to your grandparent, right? You say, no, I'm going to create myself, inform the parent informs the grandparent, right? Now, one of the anti-patterns that we'll look at later on is, it's called the diamond problem, right? So animal, dog, cat. What if you inherit from both the dog and the cat? What do you have right there? Cat, dog, cat, right? It doesn't make any sense. Java does not allow that, thankfully. The vast majority of programming languages do not allow that. The one language that allows that is C++. Gross. Right? All right. Anyway. All right. Now I'm calling the superclass there. And I'm also setting my balance in the APR. We still have some things to take care of here. All right, let's start with the getters. Ooh, do you have an account number here to return? This dot account number. No. Who owns the account number now, as in composition? The parent, the superclass up here. Right? So one thing that I could do is I could say super dot, right, account number, except that, guess what? It's private. I can fix that by using a new keyword, protected. Right? Protected, so private means that nobody can see it except for the class itself. Public means that everybody can see it. There's a nice little healthy middle ground called protected, where the class can see it and also its children can see it. There, that took care of it. That's one way of doing it. It's one of those things where you should have a pretty good reason why you want to do this. Right? There's a better way of doing this. Right? Eventually, I'm going to make it so that annuity also inherits from the account, extends account. Let's just do it. Right? And so I can get rid of these two things and pass them off. Owner and owner. Right? And if I made them protected, what I would have to do is I would have to create getters here for both of them. Right? Source, generate getters and setters for everything, select all, and also over here in the account, let me go ahead and steal, over here, right? Get account number, get owner. There we go. I'll go ahead and put that into both the annuity and the savings account. There we go. Getters everywhere. You don't need to do that super explicitly as long as everything is protected. There we go, and there we go. This should solve all of my compiler errors except for over here. Right. Oh, that's why it has it, objects. I got rid of it. I shouldn't have gotten rid of it. Anyway. All right, that solves all my compiler woes. Go back to the reason that we're doing this. DRY, don't repeat yourself. Do you see repetition now again? Yep, let's go ahead and put them side by side. What do you see here? Getters, getters, right? Getter, getter. What should I do to this behavior? Remove it. And where does it belong? The superclass. Now, there is no super dot, so let me go ahead and get rid of that. Right? Now, the subclasses will inherit those things. Over here in the demo, let me go ahead and move it back over here. I can go ahead and get the account numbers, right? For example, if I wanted to add them up, right? Double total is equal to, no, I don't want a total. What do I want? system dot, for now, I'll just go ahead and system dot out dot print s dot get account number, right? And a dot get account number. There we go. Both of them have getters for the account number. Why? Because the superclass has it, and the subclasses inherit that behavior from the superclass. Now I don't have to repeat myself. I can just locate stuff that's common to every animal up here, right? That's common to every account up here. And I only have to write it once. Everybody gets inherited. So one thing I do want to do, though, now is I want to determine how much money do I have? How many assets do I have? Right? So my total, double total, is equal to s dot balance, right, get balance, plus a dot get, well, there it's going to be terms in number of years times 12, because 12 months in a year, times a dot get, what is it? Monthly payment. There we go. There's my total. There's my total of worth, right? System.out.println. What do we call that? What's the total of assets minus the total of liabilities? Net value? I don't know. What is my value as a person right now? Let's find out. I'm worth $60,100. If I were to die today, then I would leave $60,100 to whoever's in my will. I don't have a will, right? So it's not tort law. What is it? Like family law, inheritance law, something. What is it called? Darn it, I don't remember. I'll have to look that up. Anyway, get balance, number of years times 12 times number of monthly payments. Does this look like object-oriented programming to you? No. What is it requiring me to do? Rip open the class, pull out all that data, just to add it up so that I get a total, right? Now, let's come over here to the account and think generically. Let's think abstractly, right? One of the pillars of OOP, abstraction. What is every account going to have? Whether or not it's a savings account, a checking account, both have balances. An annuity has some sort of a value like months times years times monthly payment. If it were stocks, right, a stock account, it would be the number of shares times the price per share, right? It would be different behavior, okay? So I probably want some sort of a way to get the value of that asset, get value. Now up here in the asset class, I don't know. What's the value of this asset? It's just a generic asset. A dog, if a dog speaks, what do they do? Barks. If a cat speaks, what does it say? Meow, right? And the cow goes moo, blah, 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 right? All that stuff. But if I just had a generic animal here, what would it say? I don't know, right? So if I have a generic account here, what is its value? I don't know. We could return 0. Return 0.0, right? We could throw an exception, throw defined method exception, something like that, right? I don't think that that's actually throw new, right? There we go. I'll just go ahead and go with a runtime exception. Runtime exception. I don't know how to do this yet. ... Right? So runtime exception. There we go. Return 0. So those are a couple of options. Right? We're going to come back with a better option here in a moment. Okay. For now, just to get it to compile, I'll go ahead and return 0. Okay. What about an annuity? What I can do now is I can override that behavior. Remember, inheritance is about identifying common functionality, state, and behavior in the superclass. But now down here in this in the subclasses, a dog has to bark and a cat has to meow. We have to provide some specialization. That means that we're going to override a method in the superclass. Public double get value. Tell me, what is the value of an annuity? This dot monthly payment times this dot term years times, and there are 12 months in a year, so There we go. We've seen this annotation before, override. Now we know what it means. I inherit behavior from the superclass. That default behavior is just simply just return 0. So down here in the subclass, I'm going to override that behavior and provide specialization. I'm not going to return 0 anymore. I'm going to return the number of payments, or the number of years times 12 to get the number of months, and then times the monthly payments. All right? What about account? Or sorry, not account, a savings account. What is the value there? It's just a number, right? Public double get value, return this dot balance. Or I could call the method dot get balance. There we go. I like this better. There we go. Okay. Specialization. A savings account is just a balance. An annuity is a little bit more complicated. It's 3 numbers multiplied together, right? A stock is a little bit different. It's 2 numbers multiplied together, right? And whatever other kind of financial assets you want to think about, right? A lottery ticket. What does that pay off? 0. I would say a random number generator times the $1 billion or whatever, right? And then it's a crapshoot each time you call that method, right? It's definitely 0, right? It's the idiot tax. Don't pay for it. I buy lottery tickets all the time, right? Definitely not something that you should bet on. A Chargers game. Everybody, did I mention that? Did we talk about that when that happened? Some idiot. So the Chargers were supposed to lose in one of the playoffs, right? Because they were like 99% against her. They were supposed to win. I forget which one it was. But anyway, Vegas was this idiot. It was on Reddit. I don't know if it was real or not. But this idiot puts like $12 million on the Chargers to win. But the bet was so sure, like it was 99% assured, that the payoff was only like $100,000. So he's risking $12 million for a payoff of $100,000. Guess what? The biggest upset in NFL history. They came back from like a 30-point deficit to win by 1 point or something, right? And what did he do? He lost $12 million. Right? All he would have had to do is take that money and put it into a savings account for like 5 days, and he would have gotten the same amount of money without any risk. Right? So, what does betting look like? Absolutely, it's 0 all the time. Right? Don't bet. Right? All right. So what's my total now? It's not the balance. Do I have to worry about all this stuff outside the class? It's the value plus a dot get value. Right? And then there's my total. Did I have to worry about those details here at all? Nope. It's where it belongs. Savings account stuff belongs where? In the savings account class. Annuity stuff belongs where? In the annuity class. Right? There. And I can treat all of these things as an asset. Here's another cool thing that I can do with it now. What if I had 3 assets, 4 assets, 5 assets? Right? Savings account, S1, S2. Maybe that has $200 instead. Maybe I have 2 annuities, A1, A2. And they're different. There we go. And this one is $100 for 20 years. $100 a month for 20 years. Right? Now I'm going to have to go and do S1 plus S1 to S plus 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 plus. Or what I can do is I can put it into a list. All right? Now, if I were to do this, without inheritance, what I would have to do is I would have to have a list of savings accounts. Right? My savings accounts, right, is equal to new array list. And then add them. My savings accounts dot add S1 and add S2. And I would have to repeat that with a separate list of annuities. Annuity. There we go. My annuities, right, is equal to dot dot dot. I'm even tired of typing at this point. I don't want to type anymore. Right? Because this is wrong. Do you have to separate these two out into 2 collections? Not anymore, because they're both accounts. My savings accounts, my annuities, doesn't matter. My accounts. Right? And that's going to be a new array list. And my accounts, I can add, I can add savings accounts, I can add annuities to them. A1, A1, and A2. I have one list to rule them all, right? And I can add them all up. Double total is equal to 0.0, times 0.0. And then I can go into an enhanced for loop here. For account A in the collection my accounts, total plus equals A dot get value. And then print it out. System.out .println total. Run this. Oh, wait, what's wrong? Oh, let's get rid of that. I don't care about printing the accounts out. There we go. There is the sum total of what I'm worth, right? Okay, I'm worth $84,300 now because I've got 4 accounts now, right? I treated them all generically, right? Did I have to say, oh, okay, well, this one's a savings account, so you do it this way, and this one's an annuity, so you do it this way? What if I were to add a brand new account type, checking account? Do I have to touch any code here at all? Nope. All you have to, well, other than to create a new checking account with $5 in it or something like that. All I'd have to do is come over here, create a new class, new class, new class. Make sure that I have this proper inheritance, that everything inherits from an account and is an account, and you're good to go. Now this does raise an issue here that we may not resolve yet today, but we'll definitely resolve on Monday. Account A is equal to new account, XYZ, and me. I own the account. What's the value? I have no idea, right? What type of account is it even? Can you go to a bank account and say, I want to open up an account? What are they going to ask you? Who are you and why are you here? But they're going to ask you what if they want your business? What type of an account, right? Are you looking for a home loan, mortgage account? Are you looking for a car loan? Are you looking for a savings account? Are you looking for a checking account, right? Or if they're scummy Wells Fargo, what are they going to say? Don't worry, we'll open up 50 accounts for you without telling you, right? All right, so it doesn't seem like I should be able to do this, though, just like Wells Fargo shouldn't have been able to do that. Right? So what I'm going to do is I'm going to come back over here and I'm going to prevent it. Right? So remember dog and cat. Should you be able to create a generic animal? If an animal speaks, what does it say? If you have a question that you can't answer because of the design, what you can do is you can make it abstract. Public abstract class. There we go. So this is an abstraction. It's an abstract idea. It's an animal. It's a generic animal or it's a generic account. Right? Let's come back over here to my demo. Right? And oh, I got rid of it. Undo. There we go. What does that prevent me from doing? It prevents me from creating a generic abstract account. Right? Now I'm not even allowed to do this. Even that constructor is there. I didn't change it. That constructor is there. It's still public. It exists. But by making this into an abstract class, what I've done is I've said, there's no situation in which you create a generic account. It has to be a savings account. It has to be an annuity. It has to be a specific type of account. Go ahead and make those things, but this is abstract now. Right? You can't make a generic account. That prevents me from doing this over here in the demo. Right? So now we don't have to ask that question. What is the value of a generic account? I don't know. That means that I can solve this original issue over here well, initially we said, well, it's 0. Or, no, you can't do that. We'll throw an exception. Right? Now, syntactically, you are prevented from doing this entirely. Right? And what we can do is we can make this method abstract and get rid of all of those questions entirely. Right? What's the value of an account? I don't know. I'm not even going to bother answering that question. Right? I'm going to make it abstract. The subclasses are responsible for overriding that behavior and providing what's the antonym of abstract? a concrete implementation of this. What if they don't? Guess what? It don't compile anymore, right? To be able to create this, you'd either have to make this an abstract class, which you don't want to do because you do want to create annuities, right? Or you would have to make sure that you override any abstract methods here. Right? So a cool way of organizing your code into a hierarchy, right? Note, as you're doing your design for your first phase here, you can use inheritance if you want, but since we just covered it, we're not expecting that. We will expect and grade on inheritance in phase 2, right? Where would you want to use inheritance? It should be pretty obvious. Items, item types, right? What are they? Farm Mart has what kind of items? Products, services, and what? Equipment, right? So it was all designed pretty obvious, to be pretty obvious, right? All right, have a good weekend, and baseball. Yeah.